Good morning. This is Kevin Hull at Yaskawa Motion Applications Group. Welcome to another webinar. This time we will be discussing what's new in Group Toolbox version 340. And the reason that we are going to do this today is because there was a new Toolbox installer added to our website in February 2018. Let's take a look at that first. If you go to our quick link, yaskawa.com/IECTB, like Toolbox. And on this page we have the Toolbox installers, including the latest one put out last month, a release notes which includes a listing of the individual Toolbox version numbers that are included in that installation, and also an updated Toolbox manual is here as well in both PDF and CHM format. So when you have a chance, check out the new Toolbox homepage. And so during this webinar, we're going to talk about some of the new function blocks that have been added to the Group Toolbox since its first release, which was about last year, early 2017. And so we'll give you a rundown on some of the features and benefits of these new function block additions, as well as some changes to existing function blocks, and also the enhancements that have been done to the G-code streaming feature. And as always, our purpose in creating the toolboxes is to consolidate commonly used functions and make them more easily usable in a more fully featured fashion. So we're reducing application development time by putting these function blocks together, as you'll see in a couple slides. And again, here's the background on how we got to this point in the Group Toolbox release. It took several different prior toolbox development evolutions taking place beforehand, and finally in the last couple of years we were doing a lot of G-code experimentation and PLC Open Part 4 integration with that. So at this point we have a really stable platform in the Group Toolbox v340. And on to a little quick tour of the functions. We'll start with a couple easy ones first. Get axis count and get group name. We'll pull some information out of the axes group ref, and they're kind of equivalent to what you would see in the hardware configuration. This particular group is a 3D gantry. It has 3 axes. That's pretty simple. The group name, as described in the hardware configuration, is gantry demo, as well as the variable name in the MotionWorks IEC project itself. And some of these simpler tools are useful for applications that will use, let's say, a handheld teach pendant or other HMI that may work with one or more groups on the same controller, so it can programmatically operate and manage multiple groups and dynamically show the data for the selected group to the operator. A couple other blocks here. One of them is called detect prime axes. If you have a gantry system in particular that is configured with one or more joints that has shared load, so more than one motor operating the same axis, there's a bit of complexity in enabling the group in that case, because the commanded position of each of the motors that operate the joint must be at the exact same location for their group to be enabled. So these blocks will help make that process easier. So first of all, it'll iterate through the data in the configuration to find joints that have more than one motor attached. It'll give an output called has prime if that is the case, and also populate an axis ref structure with the axes refs of the motors that work together. So with this block, we can then do another new function called align prime axes. And this function will go through a case statement sequence and essentially move the Y prime in this example to be at the same commanded position as the main Y motor. And it will only do that if they are already within an allowable tolerance. And this is for mechanical limits and for safety, that this is only meant to align axes that are just slightly out of position just from the natural relaxation process, not to bring one motor from a large distance to meet the other one where it may cause mechanical damage. So this is just to align axes that are very close. And then after this process is complete, it's an easy step to just do MC group enable. Here's another new block called group to home. And this is nice, also a state machine sequence of operations that takes place here. And this will bring your group back to a defined origin position. And it will do that in a sequential fashion as described by the data in the structure that you must populate first. So this is the data type definition that we created. And this setup code at the lower left is the configuration you would need to provide for your given machine. And in this case, it's again a 3D gantry system. And the preference that we have is that we would like to have the z-axis come up first. It's lifting positive out of the way of anything that might be an obstacle on the way when X and Y travel to their home positions. So we've configured all the axes to go to a certain position as described by this data structure, which I've also shown at the upper right here. So we're going to 0, 0, X and Y, and up to 12 on the z-axis. So those positions are being filled. And just for simplicity, all three of them are set to negative direction at first, even though we come back afterward and override the third one for the z-axis. We actually want him to go in a positive direction. So we specify the degrees of freedom by their string name, as you would see in the hardware configuration. So first off, the z goes up at the speed specified here, and once that's complete, the X and Y will go to their home positions. This block will check and detect as well if there's prime axes involved with that system. That's why we see here again on this data structure the allowance to align prime axes if they're out of alignment, and that way we'll get through all the process of group enable without any trouble. Here again you can see that the align prime axes block can be used before doing group enable. But one of the other blocks that were mentioned here is read joint map, which puts together this structure. Kind of does a correlation for you between the joint name, its number, and its axis ref. And again, this is all data to help these other blocks do their job and find the relationship between various axes in the group. Moving on to another one called plane measurement. This function block is useful in applications such as 3D printing or other Cartesian operations that need to learn a plane height and to make an adjustment in the mechanics or in the offset of the working space to account for that possible deflection of the plane. This block also runs through a state machine sequence of operations, and here it kind of depicts the motion pattern that you can get by configuring this block. The goal is to touch 3 points on a bed, and you'll have to enter the configuration data as shown here at the left. So in this example, we want to learn the level of the Z in this mechanism, in this system here. So we're going to teach points at 3 locations. And the first point will be at XY 0, 0. Let's assume that's this point here. Then for the second point, second pair of points, it'll be at X200 Y 0. So let's assume that's this point here. And thirdly, we'll go back to X0 and then Y200 for this touch point. And so if you follow along with the color-coded dots here, the approach point, the approach height, is some position above the assumed plane height where the speed will slow down to prepare for contact. So we want to kind of save time and go at a faster speed, then we'll slow down when we get to the approach height. You'll also notice the red dots indicating a negative value for all of the Z locations. And we've depicted that below the surface of the plane here in the graphic. And this is a point at which we don't expect to arrive. We don't expect to be able to position to that value. We expect to touch the bed surface before that. What we'll do is, when we reach the approach height, we will read the servopack's torque limits, their torque limit PNs, and save those, and then replace it with the torque limit specified in the structure. And so this value is in percentage of rated torque. It will be sent down to the amplifier's torque limit parameter. So we'll expect to contact the bed at 7% of its rated torque in this example. And then once we do that, we'll record the position, come back up to the approach height, and restore the original torque limit that we found on the servo pack before doing this operation. Once the entire sequence has completed, it will output the touch results as an array of z-axis positions, which can then be used to set a frame offset. So we can do a frame type transform. This block exists in the math toolbox, and you can prepare the data into this block using the results, and then also use Y group set frame offset to create a part frame offset, which represents the orientation of this plane height. So let's look at some of the slight changes we made for version 3.40. Some changes were made to the MC move path function block, just to accommodate more features and to kind of clarify or make it easier to use. We added another var in-out var data, and that's because we have some new G-code support for the use of variables as parameters. This will be a structure, an array of L-reals that can be referenced for variable data used in the path. We changed the name of this var input to velocity scalar from velocity override for clarity, because the version 3.40 firmware for the controllers now supports MC group set override. And this block takes immediate effect and overrides the live path to the velocity factor, whereas the var input to MC move path will affect motion in the future, because it's affecting only the blocks that are still to be executed and sent to the motion buffer. So there's a delay experienced when changing the velocity scalar. In terms of the reaction time, or the method used for some of these features, also we have pause input here. This again will cause a delayed pause because it will stop executing motion blocks, but motion blocks already sent to the motion buffer will continue to finish. Whereas if an immediate pause and resume is desired, then we have the new blocks introduced also in the firmware version 3.40. Use MC group interrupt and MC group continue to have an immediate effect on the motion path. There was a question about the align prime axes function block that I spoke of, and the question is, does it work even if the group is not enabled? And that is correct, because it will actually manage the group enable disable to go through its state machine process. So it is not required that you enable the group. It will take care of that itself. Okay, let's move on to some G-code solutions that are new for version 3.40. One thing to note here is that we added an abort input to the read G-code file function block, and this is handy for canceling a path that's in process that needs to be canceled for some reason. This will just stop the file read process, and then it can be restarted by re-enabling the execute function again. And we're going to talk more about the DLL feature and read G-code stream function block, which have been enhanced for version 3.40. So if you take a look at our website, we also have a new DLL available as of February 2018. So if you check for the an.mpiec.24, you can download the DLL that's available to talk to the read G-code stream function, as well as the application note and example code for this streaming demo we have available in Visual Studio. So let's take a look at this in a live fashion right now. I'll show you how this works. Okay, so I have a MotionWorks IEC project here. Okay, my gantry is homed, the group is enabled and powered, and here is the read G-code stream function block, and I'll run the G-code streaming demo. Alright, so the IP address of my controller is 201. And you can see here this function block is running right now, and it's busy and valid, but it's just listening for a connection from a host application. So when I press connect, you can see that the Boolean output host connected came on, and also it reports the IP address of the host PC. So at this point there's a connection established, but there's no G-code being sent yet. If you can see this status bit toggling 1 and 0, this indicates that there's a packet of information being sent back to the host, back to the DLL from this function block. So every scan rate, depending on which task this function block is executing in, there is a packet of information being sent back to the DLL so that the program can understand the situation going on down at the controller. And this is an expanded view of the data that's being sent. Let's move this over here. So we call this the stream struct, or this is the status packet. And if you look in the Toolbox manual, you'll see that on page 366 in the PDF, all the data that's in here is described. A couple of touch points though to talk about. An in-use flag lets us know if motion is currently occurring using the streaming data. A lot of the buffered data in here is used to determine if there's availability on the controller side for more G-code data. We are showing that as a status on these scroll bars in this demo. And if there was any errors on either the read G-code stream function block or the move path function block, you can see those here, as well as other status outputs on that block if they were set, such as the output flags and the other status outputs here. So let's go ahead and find a file to send. And we can optionally see the graphic of the plot as it occurs. It's going to be kind of a crude representation of the actual motion based on the update rate here. But okay, so we have a file, and the next thing to do would be to send that file. So now you can see everything comes to life here in the streaming demo. The file has already been sent in its totality down to the controller. That happened in the first couple of seconds when the first scroll bar had some data that diminished here. And then it all got through the buffers and is still in the MC path data ref buffer as the motion plays out. There's some useful information in this status struct as well. It gives us the byte offset, for example, of how far into the file we are at this current time. So if there ever was a fault or a reason to stop the path, the host application can read the byte offset and do things such as resume a path in the future at the last known good motion coordinate or point that was given. And there you have the read G-code stream and new G-code COM DLL that we have available for use with version 340. Let's take a moment to check for any questions. Okay, there was a question just curious about the scan rate that we used in the demonstration we just showed. And right now these blocks are running in this HMI POU, which is running in the slow task, which I believe is set up at 48 milliseconds. Yes. So every 48 milliseconds, a new UDP packet of information is sent back to that host program with the data for the positions and the buffer status. And that's relatively fast. Even though this is in a slow task, it doesn't need to run any faster. It handles relatively large chunks of G-code data and keeps the buffer full, which is the most important aspect of what it does. If we take a quick look again at some of the data that's in there. And by the way, this MyPath structure and the stream status structure is the same as what we just saw on the G-code streaming demo. The stream status is what's sent over the UDP message. We have a status flag here called bytes utilization, and this can be used as a metric to understand how many scans as a percentage of all the scans that this block is busy processing byte data from the host. And I think a good rule of thumb is somewhere in the lower percentages, like 20 to 40% is a good number. It indicates that it's more stable in terms of surges in data being processed. If the number was high, that would mean it's quite busy and trying to process every scan. And if it's quite low, that means that the data is kind of coming in these spurts that make the block run harder on infrequent scans. So byte utilization somewhere in the middle percentage is ideal. There was a question about do we have the ability to do an immediate stop and pause function from the COM GUI? And the answer is no. However, That's because the COM GUI right now has a DLL which is dedicated to sending the G-code stream. So it doesn't really have any other communication input to this MotionWorks IEC project. But coming later this year, we're working on another DLL that will help further enhance the front-end interface capabilities, and it will have other commands such as servo on-off, homing, jogging, and alarm clear, and of course the ability to invoke the immediate pause and resume. So look for that later on in 2018. And let's take a look at a few more new features in version 3.4.0. We've added several new G-code commands. The first one here, G10, a work coordinate offset. We've kind of changed the behavior of it internally because now with firmware version 3.4.0 we have support for PCS offset using the group set frame offset function block. So now this is used internally, and it allows more flexibility in doing part coordinate systems than we had before. Also, the subroutine calls and the ability to do variables and logical jumps all make this program possible. So in this short G-code program, we can demonstrate the ability to do this clover-shaped picture with 4 arcs and then do a repeating pattern by incrementing through some variables and through some iterative statements here. So the actual arc itself is just these 4 lines down in the subroutine, and you can see that they're all hard-coded values for the coordinates of the arc, and we can get away with that because they're all within a part coordinate system. It's the part coordinate system itself that's being changed using G10, and these variables, the variables simply called 1, 2, and 3, to change the x, y, and z of the work coordinate system offset. So just taking a step back, this is kind of the initialization of the program. This kind of acts as the main loop, the main core of the program that jumps down to a subprogram 8 times. This being the subprogram that has the actual motion and the setting of the part coordinate system. And so let's take a quick look at a kind of a time-lapse video of that running. So there's 2 repeat loops there. One is 8. It's 8 by 8, so we get 64 different clover patterns drawn based on the same actual arc segments here in the subroutine. Okay, and that is the conclusion of what's new in Group Toolbox v340. Look for more changes coming this year, and don't forget to check the Yaskawa home pages for the IEC software, IEC firmware, and IEC Toolbox pages for all the latest updates. There was a question about the scan rate that the MC move path was executing in, and I typically run that faster than the G-code stream itself, and in this project it's in the I/O task, and the I/O task I believe is running at 4 milliseconds or 8 milliseconds. It's 4 today, and it doesn't really need to run that fast. That all depends on the data you're processing, and if you have a motion path that has generally large distances between segments, it's not necessary to run this block this fast unless you were controlling outputs along the way. That would be the one major factor in determining where this block is best suited, because it will monitor for the current live motion segment and then be able to track and set the output flags appropriately, and that is more accurate, of course, the faster this block scans. Otherwise, it's preloading a buffer of the motion instructions. There's no real critical need to have it running in a fast task for that reason, because it will prepare the buffer in advance. In this case, the group's buffer is set to 128 motion segments in the firmware layer. So as long as the next motion segment is the same as a linear segment or successive linear or arc segments, and they are collinear within your specification given by the myPath.collinearity flag, and that's this one here. So any two segments that are within 30 degrees angle of each other, it will continue to execute and send to the motion buffer in advance. So that leaves the motion buffer with plenty to work on between scans or between times when the move path will start to process more functions. There was a question if we have any plans to handle custom G codes, and yes, we've done that. We have a couple custom ones in there currently. If you check the Toolbox manual, there's a listing of the supported G codes, which includes a couple that were added custom for turning on and off a tangent axis, and we can add others as we need. All right, I think that's all the questions we have for now. Thanks again. Have a great week.